Hello, everybody. Welcome to episode 4. In this episode, we will talk about the character of water. And as always, I'm here with my co-host, Elena Berg from Paris. And in this episode, we will explain why water is not just water. And in some of the previous episodes, we have mentioned that water dissolves everything. So there is no pure water. Pure water is very bad. You shouldn't be drinking it. And as soon as water gets in touch with something, it starts dissolving it. And think of that when you think water is just water, because water is not just H2O, the water. It's water plus all the thing it dissolves when it gets in touch with the environment, the ground, or even the air. So think of water more like a cocktail of many different things around water and not just as H2O. So I think we want to talk to you about in this episode what you need to look out for in this kind of context so you understand why water is not just water.
So a major way that people distinguish different waters from each other is minerality. Minerality is it's measured through TDS, which is the total dissolved solids. Essentially what that is if you took a water and you evaporated off all of the H2O, all of the pure water, and you measured or weighed the rest of it, that's what you would have left over, and it's measured in milligrams per liter. So that's all of the minerals basically in their dry form. So minerals might include calcium, magnesium, sodium, silica. There's all kinds of different minerals that might be included in this. And typically potable water that we can drink ranges anywhere between 0 and around 5,000-6,000 TDS. A lot of the taste test studies that I'm reading, have been trying to, these are often conducted by people interested in optimizing the flavor of tap water. And typically people prefer a range between sort of 1 and 400 TDS, and a lot of tap waters have that range. But there's also very low minerality waters. So iceberg water and glacial water is very, very low. Rainwater, very low TDS waters. And there are also really high minerality waters that people can enjoy. So one famous example is called Roy, and that minerality is over 7,000, I believe. And you would not drink Roy for hydration. You'd be drinking it the way you would sip a fine whiskey. So it has a really interesting flavor, may or may not have sort of digestive properties, etc. But it's not a water you would drink normally. Another related measure of minerality is called hardness. So this is pretty familiar to everybody when they think about whether they have hard or soft water in their home. The hard water, typically you think of as you get those calcium deposits. Soft water is much smoother. And that's a ratio of calcium and magnesium. So it's basically a formula for working out whether your water is hard or soft. Do you have anything you want to add to that, Michael?
Minerality, very, very important for the taste of water, how the water tastes. And another aspect is the carbonation. We are very used to having, the still and sparkling versions. And I would say, 98, 99% of the water you drink as sparkling water is artificially carbonated, or the carbonation has been added. So what comes out of the source is still water, and CO2 is added in the factory before it's getting into the bottle. And at this point, you can also adjust how much carbonation goes in there. Is it a little carbonation or is it more carbonation? And that has a big impact on the water too. As you can imagine, there's a big difference between drinking a still water and a carbonated water. And many people have preferences between still and sparkling. There is also a very small, tiny category of waters that are naturally carbonated. And what that means is there are a couple of reasons for it, but there usually is volcanic activity near or below the aquifer where the water comes from. The CO2 seeps in from the volcanic activity, seeps into the aquifer, and when the water emerges, it's already carbonated. So it's very rare, it's very special. I've been to many sources where you see some artificial carbonated water, and it's also always very special to drink something that's natural and carbonated. And for me, that's a really, really interesting thing to know, because we're so used to the carbonation, but you have to look back into history, and artificial carbonation is only possible since, you know, the very early 18th century. Before that, it was either still water or carbonated water. And we talked about Rome importing naturally carbonating water because this was the only way of getting naturally carbonated water back then.
Yes, I think one of the things I wanted to add to it is what I've noticed in the water market is this, many companies that like to have both a still and a sparkling version of the water, sometimes several degrees of sparkling water. So it's interesting how much you have something that's artificial, but that's sort of permitted to be added to water. So in the EU, regulations for mineral water are extremely strict, but one thing you are allowed to do is to add carbon dioxide to the water. But again, I would agree that it's really quite special when water is naturally carbonated. Sometimes what happens is that carbonation has to be kind of re-injected because when the water surfaces, it often loses a lot of that carbonation. So there are controversies and methods around like what does it mean to be naturally carbonated, and the idea is that what the water at its source has carbonation in it that you can then pull out and taste.
Yeah, interesting. You mentioned the natural carbonation, getting the natural carbonation in the bottle. You're absolutely right. It's very difficult because usually in the bottling process, the artificial carbonation disappears because of the many pipes involved the water has to run through before it's in the bottle. So what usually happens is that in the ground, the carbonation gets separated and the water gets bottled, and the carbonation gets then re-injected, as Elena said, into the bottle again at the last minute, so the carbonation stays in the bottle. You would think that's similar to artificial carbonation, but it's not. The reason being is the water has been with the carbonation for a very long time, sometimes thousands of years. So think of them almost like a married couple. They get separated for a couple of minutes during the bottling process, and then they come together in the bottle. And the carbonation has all the minerals to hold on in the water. So if you open a naturally carbonated bottle of water at the table, you will notice that the bubbles stay there much, much longer because there's a kind of a grid and the CO2 can hold on to this grid. Usually naturally carbonated waters are also much higher mineral content, but there are some waters that have a low mineral content are still artificially carbonated and still have a longer bubble time, so to speak. While an artificially carbonated water is, in my opinion, almost like a forced marriage. There's a separate water, there's a separate CO2, and they're getting forced together in the bottle. And if you open the bottle, they don't want to stay so long together because they're not used to each other. They don't have the same composition that allows them to stay together.
I love the imagery of the married couples, or the ones that like or don't like each other so much, or haven't spent so much time around each other. Another thing that impacts the sort of different taste profiles of water is pH. So arguably pH is less central to how we detect flavor, but water may be more acidic or more alkaline. One thing I did want to mention with that is that there is a big craze now to drink alkaline water with the idea that if you drink more basic water, it'll be better for your body. But in fact, our stomachs are so acidic that whatever water we drink will immediately become acidified in the stomach. So that whole concept is not really supported by the science.
Yeah, it's funny you mentioned it. I'm sure we'll get some comments below from people who believe and, almost like a cult following in drinking alkaline water in the face of any kind of scientific evidence and, lots of evidence to the contrary. Why do bottle brands put alkalinity on the labels and use that? Is they don't have anything else to tell. They don't have a story. If the waters we are talking about are natural waters, meaning they come from a real place, they come from a source, they have a story, they have a history. Many of the alkaline waters are processed waters, and we'll talk about the difference later, but they come out of a factory. It's not a very sexy story to tell you, yes, I'm municipal water that was purified. We added a couple of minerals and alkalinity, and now this is really healthy for you. So every time you see an alkalinity story, it means there's nothing else to tell. So please don't fall for it. It has no scientific evidence, and our bodies are very, very, very capable of maintaining a very narrow slice of pH in order to sustain our life. And we're very good at it. We have been doing this for, hundreds, thousands of millions of years of maintaining our pH by ourselves without, having to rely on alkalinity water.
Yeah, so I think that this is a good time to transition into talking about what the sources are. And maybe the first place to start would be to talk about the water cycle. So how do we keep getting water through time? So as we mentioned in the previous episodes, we got all of our water originally from outer space, essentially, and that eventually filled up our oceans. And basically, what happens is that there's evaporation, either from water surface, or plants also give off what's called transpiration. They give off liquid, and eventually that water condenses again and comes down as rain. So all of the water that we drink has its origin in rainwater. And the question is whether the rain has just landed and we're capturing that water, or whether it's percolated through the earth for 10,000 years or however long, until we're finally drinking it again. So the amount of time that water has spent moving through layers impacts the amount of minerals that are basically locked into that water, and also the types of soils, right? So different soil, different rocks have different character, different mineral content, and that will affect the flavor of the water as well.
So if we look now at the different sources of water, the first thing, of course, comes to mind is the surface water, right? It's the river, the lake, the dam that, we might have built. And I'm certain, and, it's pretty clear that for the longest time of our history as humans, this was most likely, together with rain, the source of our water. And sometimes we see this, pristine rivers, we see this pristine lakes, and right now we think, oh, that's very nice to drink, let's have a sip of this water. And right now there are very, very few brands that bottle from surface water. There are some in Alaska I know of. They're using, very deep glacier lakes and extracting the water from the bottom of the lakes, and just have to filter the water and UV it. And this can be drunk. But recently there was a little bit of a craziness with what's called raw water. Suddenly people thought the best idea is to go back to nature, drink raw water. So they went into the mountains, they went into the forest and just collected water from open, surface water. And I don't think that's a really good idea, especially if you're not used to drinking this water. There's still a lot of microbes and bacteria in the water, even so if it looks very clear to you. So our recommendation is right now, unless you're very certain about the source and have it tested, not to drink surface water.
Yeah, I think that's right, that we lived alongside these water sources and used them until we figured out how to drill down into groundwater, right, with wells, which did happen, I guess, about 10,000 years ago, or maybe more. We figured out how to drill down and get access to water. But most of the water, a lot of the Roman aqueducts, were coming from rivers or streams, right? But there weren't very many people. There wasn't a whole lot of pollution that was going into these waterways via runoff. Right now, worldwide, because of population density and just the way we interact with our environment, there are a lot of pesticides, a lot of herbicides, a lot of other chemicals, basically, that end up in surface water. So typically surface waters tend to be more polluted and need to be a little bit more careful with drinking them. That said, a lot of the municipal water supplies do rely on reservoirs, right? So you dam a river and it pools up, creates a reservoir. But remember that for these municipal water supplies, there's a fair amount of treatment right, before you actually get the water. So that isn't a big problem if you have the infrastructure to filter out those things. The difference between those kinds of water sources and the mineral waters that we'll be talking a lot about is that those waters are typically drawn from other kinds of sources, for example, artesian springs, which are springs that are basically water underground that's been compressed between two solid layers. So it's under pressure, and that people tap into that, and that water comes up sort of with pressure. Or spring water, you can have underground rivers that then pop out at various places, maybe along the side of a mountain or something like that. Everybody has familiarity with the little mountain springs. So there are other places where people have been getting water that's not just surface water.
Yeah, so many different sources. Elena mentioned spring, the classic source. You know, if you talk about water, bottled water, it's spring water. Only fairly recently, let's say the last 10, 15 years, was the distinction made between the spring, which is gravity fed, and the artesian spring or artesian water that's under pressure and therefore emerges from the ground. And both waters, you cannot say they have a certain characteristic, because it again depends where the waters lived for the rest of their lives, for their previous life. You know, sometimes spring water is very young. It's maybe rain from last snow season, or at least at the minimum 2 years before that. So it's very, very young. The water only takes 1 year or 2 years to go from snow to the spring. Sometimes spring water stays in the ground for thousands of years. So again, how much time it has to absorb, totally changes the characteristics. So a spring water doesn't have a unifying characteristic. It has a subset, then depends how long it has been in the ground, what is the geological strata. And the same is true for the artesian spring. So I think very important differentiation. And the important thing is that with both spring and artesian water, the water is given to us. It doesn't mean we're extracting or pumping the water out. If you are, what we will later see with the small water farmer, the idea is that nature gives you the water. We're taking the excess of water. The water would run out of the spring anyway. The water would come out of the artesian well anyway, and the water is giving to us, not exerted. This will become a big differentiator in the future.
At the same time, I think it's really important to recognize that if you hadn't taken that water, right, it might have an impact on that ecosystem and that environment that you might alter by taking that water. So one of the big challenges that these companies have when they're extracting water that they're not just using for their own sources, but they're bottling it and distributing it, they have to think really hard about how much water they can extract from even that artesian spring, right, without it having an impact, a negative impact on the environment surrounding that area. And it's a tricky thing, because sometimes water is historically been very, very tricky for us to work out, because, for example, ownership of water is very difficult to figure out. Water moves. So is it the place you're in and the water that moves through at that time through that place? What if you don't take any of that water? Do you lose access to that water, right? There are all sorts of complicated rules around how we take ownership about water and how we take responsibility for water. So I do think one of the big challenges that these small water farmers have, if they're going to be environmentally sound, is to figure out what is sustainable and how can they use sound science to demonstrate that extraction is sustainable.
Yeah, absolutely. I think the amount of water extracted is very important, and we'll have a whole episode about exactly those kind of issues. So we talked now about surface water. We talked about spring and artesian water. Well water was briefly mentioned. Yes, this is when you have the feeling there's water underneath, and you start digging a hole, and suddenly at the bottom of the hole you have the water. Everyone knows that, and you can either pump it or take a bucket and get the water out. Again, technology that's at least 10,000 years old, but maybe even much, much older. The people were looking for water, especially when they started settling and needed water, especially in position where they had to defend themselves. They had to look for water inside, whatever the defenses were. So well water is also very well known. We also now have a source of water for bottled water. That's rainwater. And again, it's a source that has been exploited for a long, long time. Many people around the world still using well water. I lived in a small remote island, and most of the water I drank was rainwater that we collected from our roof. And in a special location like in Tasmania, very clean air, no industrial pollution, rain is harvested and bottled. And that's also a very, very interesting source of water. And as we mentioned before, the waters we're talking about here are not really just for hydration. This also has some experiences, and we have a whole episode about the experiences around water. But let's continue here just for the moment with the other sources we have for water, because we have another interesting source of water that was rain at some times, but now it's something different.
Exactly. So there's a couple of other waters that also are very low TDS, like rainwater. So iceberg water, for example, or glacier water. So iceberg water typically is very difficult to harvest. And a lot of people, what my initial feeling was, oh my God, how horrifying. We're going to steal the ice from the poor Arctic animals that need this ice to survive. No, in fact, what happens is that boats go out and will find floating pieces of iceberg that have broken off from the main iceberg, and they have to harvest ice that has been ice for a very, very long time. So in order to ensure that it has absolutely no contaminants in it. So they become sort of experts in being able to identify ice that's many thousand years old, and they harvest that. These are chunks of ice that would otherwise melt into the ocean, so they're not doing environmental harm that way, though. Of course, the energy it takes to take your boat and go out there and extract the resource is something that we need to consider. We'll be thinking about all this in future episodes. But that's one really exciting kind of water that people are intrigued by. Very low TDS, very, very low mineral content. Glacier water is generally the runoff from glaciers. As glaciers are melting, they melt into deep pools or underground rivers, and then that ice or that water that's been recently melted gets harvested. So there's Iceland is well known for its glacial water.
I find it fascinating stories that you could have a bottle of rainwater and from Tasmania, and that's water that probably fell a couple of months ago, and you have it in your bottle. And if you remember our episode where we talked that we still have some comets and ice coming in from outer space, evaporating in the atmosphere and falling as rain. So sometimes if you open a bottle of rain, you might get a couple of molecules from 5 billion year old water that was floating around in space for a long time, and now it's in your bottle. And at the same time, next to it, you can have a bottle of iceberg water, and that was rain that fell as snow maybe 4,000 years ago. And both waters drunk next to each other, most people would notice a difference. Even so, they have a very low minerality, a low TDS. Just this different treatment and a couple of thousand years made a difference in the water, and you notice the difference of waters. And we've talked about all these sources, and we want to make you interested in exploring water. Because as I said at the beginning, it's not just H2O. It's a cocktail of many, many, many different things that are in the water, and that gives water character. It's the source, how it has been treated, how it was in contact with the geology, that gives it that kind of interesting thing. And it's important to try to sample many different waters in order to notice it. If you just drink a very small slice, you will never have that experience of many different waters.
Yeah, I agree. I think that was part of the discovery process for me in kind of starting this whole journey, was realizing that actually the kinds of minerals and the history of those minerals' contact with the water really impacted how I perceive the flavors. So we hope, if anything, this will at least inspire you to check that out and just see for yourself. I think this is a a good time to think about the difference between natural waters, right, which we've been talking about, like all these sources of water. There are other ones too. I mean, deep sea water. People are extracting waters directly from clouds, right? So there are many sometimes fairly ingenious sources of water that people are bottling. But what is the difference between natural and processed water? So natural water, the sources we just described. Processed water is water that's been taken and put through a series of processes. So whether that's filtration through layers of sand, different kinds of sediments, or chlorine, right? Chlorine was, I think we talked about that in the previous episode. Chlorine was this unbelievable discovery, right? That suddenly there was a substance that actually killed a lot of the microbes that were killing people. So it may be fluorination is an example of a processing, right? That in some communities, fluoride is put in the water and that helps teeth develop to be strong, but it's controversial. And then other recent ones would be UV filtration or UV radiation that also kills a lot of the things that harm us. So there are various different techniques basically that people use to clean water, and this can be central. These technologies are central to human health. So we don't want to demonize the process of processed water, right? This is what generates the tap water that people can drink, right? And this is the process that we need to see in order to make sure that people who don't now have access to clean water, to make sure that they do in the future. So these technologies are central. And a lot of communities that suffer from a lot of drought, a new technology that people are turning to a lot is recycling water. They'll take wastewater and they'll completely recycle it, right? So that when at the end they produce a water that's fully drinkable. What is a little more difficult for us to sort of negotiate is the processed water that's then put in bottles. So this is what we're talking about, big companies that take municipal water, maybe put it through an additional process, and then put it in a bottle. So a couple examples of that would be Aquafina, Dasani. I've been living in Europe too long. We don't drink a lot of processed waters here. And this is, I think, the contrast that we're trying to set, right, is between these natural waters that have all kinds of character and water that's been processed and sold as an alternative to tap water, right? Where tap water then gets demonized when in fact tap water is central to our lives, gets demonized and turned into a commodity that people drink. Again, we'll talk more about this whole process of water as a symbol next week. Do you have anything you want to add to that, Michael?
Yeah, I think this is really the key here, making and pointing out the difference between a natural water and a processed water. And it's not black and white. There are many small aspects that can fall on either side. But let's stay in the big picture. What does it mean? We're all familiar with natural food and processed food, right? Many of us go to the farmer's market. We know where our vegetables coming from. Maybe we have a relationship, if we eat meat, the people that raise your meat in a very humane way, get some very happy cows and pigs. So we engaging with where our food is coming from, and we make sure we can attach the label natural or organic to it. So we have that emotional relationship with our food. And again, this is if we have enough food. You know, there are many people that don't have enough food, and this becomes a problem. But in the Western world, where you can engage, where you have the resources to engage with your food, that is the trend. It's the farmer's market. It's the natural food. And then on the other hand, we have processed food. And we know this is the stuff that you get at McDonald's and similar outlets. And I would make the argument it's not really food. It just looks like food because it has been processed. So I would like to apply the same kind of logic to water and say there's natural water. What does it mean, natural water? It comes from a natural source. We've talked about the sources. When you drink natural water, it should be as close as possible to the water that is at the source. So ideally, if you drink straight out from the source a cup and you open a bottle of the same water and you drink them, they should be identical. And for me, that allows you to make this emotional connection, and the water is altered as little as possible. Elena lives in Europe. They have, fantastic standards. And if it's a mineral water, it has been minimal processed. The only thing that's allowed is a quick filtration to get out of any kind of sand or other elements. And sometimes if there's too much iron in the water, it's allowed to remove the iron. But other than that, the water you're drinking is the same water you're drinking at the source. Different standards in the US here. We sometimes allow UV filtration in order to process the water, and we allow ozonation to taste the water. Both of them are tasteless. I have tasted it at the source and from the bottle. I didn't notice a difference, but there's a minimal processing. And the processing is done, of course, for safety reasons, because water is a fantastic vector for diseases. We're so happy we don't have that anymore, and we want to keep it this way. So that for me is the difference between, this is natural water, and what is processed water. As Elena was saying, processed water is running tap water into a factory in the middle of the city, removing some of the minerals from the tap water, adding some minerals that a focus group has determined is what people want, putting this back again and putting this in a bottle. So if you go to the supermarket, you actually see two completely different products that, if you don't look closely, appear to you as be the same, and you call it bottled water. There's no such thing as bottled water because it's two completely different products. One is as natural as possible product, akin to the food you get from the farmer's market. The other thing is something very close to what you get at McDonald's, highly processed, manufactured food, which is the processed water. They're just sold in a bottle, and if you don't pay attention, you think it's the same. So for us, water is not just water. This is one thing you need to be aware of, naturally versus processed.
Well, I'll disagree a little bit, I guess, with the sense that it's like McDonald's, because I do think that putting it in a bottle is it maybe akin to that, right? Like if you put it into a bottle and you commodify it, you sell it, that feels to me like a very different process. But I'm extremely pro tap water, and I actually love Paris tap water, and I drink it almost exclusively. For me, my love of mineral water is an accent. It's something that I seek out and I drink when I'm looking for a sort of a moment, a period of enjoyment with my food, or even on its own, right? I just want to taste and enjoy those different flavors. But for me, those mineral waters are not for hydration. They are not, I rely heavily and support my access to healthy tap water. So everybody's different this way, right? Not everybody's gonna have that same relationship with tap water. And tap water is a processed water, but it's definitely not McDonald's. So I think it's more about the context in which it's bottled and advertised and sold, rather than the fact that it has been processed, because thank goodness we have processing, because otherwise people would not be able to thrive.
Yeah, very, very good point. And I didn't mean, what I was trying to make the difference is that there are two different products that we call bottled water, and they're very different from each other. One is a natural product, the other one is a processed. And when I talk process, I talk about the process of the factory that takes the tap water, alters the water, and puts it in a plastic bottle. I'm also a big fan of tap water. I come from Austria, Vienna originally. We pride ourselves of having fantastic water, and it's really nice. I come back to Vienna, I drink tap water. So it's not, as Elena was saying, it's not bottled water versus tap water. Again, tap water, perfectly good for hydration. We use it for hydration here. Unfortunately, our tap water down here where I live currently has a very strong taste that's not very good if you do want to do some fine cooking. So we use a reverse osmosis system in the house to have the water. But for most hydration, for most cooking, we're using the tap water. So it's really not this dichotomy between bottled water and tap water. Tap water is perfectly good for hydration. If you enjoy your water, drink it. But as Elena was saying, the bottled water from a natural source is something that accentuates it. Something like opening a nice bottle of wine. If you open a bottle of iceberg water, this is not for brushing your teeth or for because you're thirsty. This is because you sit down at a table, you have friends there, and you say, you know what, to this fish or to this sushi, I think a bottle of iceberg water would work nicely. And guys, this water is 7,000 years old. Have a sip. This was rain that fell in Svalbard and some other, Nordic regions. So it's becoming a vector for experiences, not only for hydration. But again, the processed water in plastic bottles, I think, is something that we need to look at if we want to talk later about the plastic and the PET, because it doesn't make any sense. You have basically the same water in your house, and now you go to the supermarket and you buy cases of PET bottles with basically the same thing in it, and you pay much, much more than you could from your. And why do you do it? The reason is not knowing enough, number one, and number two is very deceptive and very clever advertising.
Exactly. We're gonna talk about some of the bigger companies that bottle processed water and some of the practices that they use that I certainly don't agree with. So I think I think the main message here is that, again, with our water is not just water message, which we've been telling you about, is that even among bottled waters, you have vastly different playing fields. And a lot of people don't appreciate that. I've been inundating myself with all of the literature, and there are whole books that talk about bottled water and don't ever distinguish between any of the kinds of bottled water. They just treat all of them as a homogeneous group without distinguishing between small and big companies, processed water versus natural water, kind of those companies' profiles, what their designs are, how that water should be enjoyed. So the next episode is going to really focus on this, what we're calling the small water farmer, right? Which is this small producer that is producing a small amount of water, generally at a higher price point, right? There isn't a big production. Often that water comes in glass bottles, though sometimes it's in plastic. But this is generally low production water run by small companies with people who have a really strong connection to the land and generally have a really cool story to tell about where that water comes from. So next time we'll talk about many of those different companies, or at least a few really cool examples of those, including some that have made particularly strong environmental efforts.
Fantastic. Looking forward to the next episode.
Yes. Talk to you next time. Goodbye.